Hello everybody, welcome into another lesson. So today we are going to talk about parallel lines, skew lines, transversal lines. We'll talk about some planes, and we have one new theorem. So let's get into parallel lines. I'm sure most of you are familiar with what parallel lines are by now. They are two lines that never touch. Well, that's partially true. That's only half the truth. The other part of the truth is that they're in the same plane. For two lines to be parallel, they have to be in the same plane. And they never touch. So that's the true definition of parallel lines. They're two lines that are in the same plane that never touch. Here we have lines L and M. L and M are therefore parallel. They never touch. So shorthand, you could say line L is parallel to line M. And that's how you would write that something's parallel. You would use that symbol in the middle. L is parallel to M. Okay, so there's parallel lines. That's pretty simple to understand. We're going to talk about another type of lines here. They are called skew lines. We're going to talk about what skew lines are next. So let's see here. Let's draw two separate planes. I'll call this will be plane A, this will be plane B, and then we have line L here in plane A. We have line M in B. Alright, so I have a line L in plane A, a line M in plane B. When you have two lines that are in separate planes, those are called skew lines. Skew lines are neither parallel nor intersecting. They're kind of a special class of their own, and you probably haven't heard of skew lines until now, but skew lines are neither parallel nor intersecting because they're not in the same plane. So line L is skew to line M, and you would just have to write it out, L skew to M. There is no abbreviation for it. So those are skew lines. They're non-coplanar lines, if we want to get using technical terms. All right. Just like lines can be parallel, we can also have parallel planes. So we can have parallel planes here. We can say here, this is plane A. I'll put it right in the middle. Here's plane A. Here's plane B. Parallel planes are two planes that never touch, just like parallel lines. So you would write plane A parallel to plane B. That's how you would write that. Plane A runs parallel to plane B, so those two planes never touch. Pretty simple stuff. Okay. Let me draw a box here. Do my best drawing. My best drawing. Oops, that's not correct. Alright, so I have a lovely box drawn, or maybe not so lovely, depends how you see it. Well, let's see now. How do I want to set this up? This whole top portion, now we'll make that plane A. This one here will be plane B. Alright. Let's name off some points. Let's see, we could have point C, point D is right there, point E here, point F here, point G here, point H here, point I here, point J here. Okay, so what I have, of course, is a box. Now, a line and a plane can be parallel if and only if the line and the plane never touch. So, let's look here. Let's see. We have here line CG, don't we? Well, that'd be parallel to plane B since line CG and plane B never touch. So, you can say that line CG or GC, however you want to. Yeah, we'll just call that GC. It don't matter where you start for the line. Line GC is parallel to plane B. Because line GC and plane B never touch. You can also say that line FJ, we have line FJ right here is parallel to plane A because line FJ and plane A never touch. So a line is parallel to a plane if that line and plane never touch, or never meet. So that's something else you can have. All right. And then we need to talk about something here. So I'm going to set up two planes. We will call this plane, this will be plane A, this will be plane B, then we're going to draw a third plane that runs through these two planes. We're going to draw a third plane that runs through these two planes. We will call this plane C. And then what we have here, line L, line M. Okay, so if you have two planes that are parallel, and then you have a third plane that intersects both of those planes, that third plane is called a transversal plane. So you can have a what's called a transversal plane. I wrote the term here, transversal plane. Again, that's if you have two or more parallel planes, meaning they never intersect, but then you have another plane that intersects all of them. That's a transversal plane. Okay? And I'm going to write down a theorem here. We're about to write down a theorem. The only one we're going to get today, the only theorem we're going to have. This theorem states that if two parallel planes are cut by a third plane, then the lines of intersection are parallel. So this theorem here states that if two planes are cut by a third plane, so we have planes A and B, they don't touch, they're cut by a third plane, plane C, then the lines of intersection are parallel. So what that's saying is, for this example, that line L would be parallel to line M. Because we go back to the definition of planes intersecting. When we talk about planes intersecting, the point of intersection of two planes is a line. So plane C intersects plane A at line L, plane C intersects plane B at line M. What that's saying here is that line L is parallel to line M. And yes, we are going to prove it. You know, I couldn't let you get off without a proof today. Certainly not. So let's see what we have here. We are given, what we've been given here is that plane A is parallel to plane B. So plane A is parallel to plane B. Plane C intersects plane A at L, and then plane C intersects plane B at M. So we were given that plane A is parallel to plane B, plane C intersects plane A at L, plane C intersects plane B at M. Whoops, I should lowercase m because it's not a plane, it's a line. A line would be lowercase. So what do they want us to prove? They want us to prove that L is parallel to M. We have to prove that line L is parallel to M. So let's go ahead and get started here. Alright, this could get interesting. I'm going to try to keep this as neat as possible. Statements here, reasons here. So statement 1, we could say that plane A is parallel to plane B. Plane A is parallel to plane B. That was given to us. Okay? And then we can say that we can list part 2 for given also. Plane C intersects plane A at L, plane C intersects plane B at M. That was also given to us. So we have both givens for first and second statement. Where do we go from here? That's the next thing. Well, again, we know that plane A and B are parallel. Now, isn't it true that line L is in plane A as well as plane C? And isn't it also true that plane M is in plane B as well as also C? Yes, it's true, because that's where those planes intersect. So we can say L is in A, M is in B. That's also given by the diagram. So we've had 3 givens so far. Alright. We've had 3 givens. No, L is in C is what I meant to say. Excuse me. M is also in C. Okay. Now we know that L is in C, M is in C. We know for a fact that lines L and M don't touch, right? Lines L and M don't touch, so therefore they must be parallel. Step 4. Line L is parallel to M by the definition of parallel lines. By the definition of parallel lines. We can say that L is parallel to M since we know that they don't touch. Line L is parallel to line M. So I started with for the first 2 statements, I listed the whole givens. Then step 3, I said line L is also in C as well as line M. They're both in C, right? They're both in plane C. And since we know that those 2 planes don't touch, by the definition of parallel lines, line L is parallel to line M. So that actually wasn't that bad of a proof. That really wasn't. Not at all. But you have that in your toolbox now. You can use that for future proofs if you have something similar, that if two planes are parallel and a third plane cuts them, then the lines of intersection are parallel. You can actually use that in future proofs. Okay. Now, let's go on to transversal lines. No theorem about transversal lines today, but in the next lesson there will be. So, let's draw nice big diagram here. Okay, let me just set this up a minute here. Let's get some angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so what we have here, we have two lines here that go from left to right being cut by two other lines that go from top to bottom. Well, you have your two normal lines that go from left to right in black. These two lines that go from up to down that cut through those two lines are called transversal lines. So you would have transversal lines. So these lines in blue that go from up to down are called transversal lines because they cut these two lines that lay straight down. Or you, if you want to, you can argue that the black lines are transversal lines for the blue lines. Either way, you have lines intersecting lines that don't touch, so those are transversal lines. Well, why do I have angles there? Because this is going to be very important for the next lesson. Today we're only going to classify the angle types. The next lesson we're going to talk about congruence of these angles and get some theorems with those. So the first type of angles formed from transversal lines are called corresponding angles. So we have corresponding angles. Well, what are corresponding angles? So let's look at these two lines that run from left to right, okay? We have here, let's look at angle 1. Let's start with 1. It's in the very top left of the line, is it not? Well, angle 9 is in the top left of the second line of the bottom line. If they're in the same position on each line, those are corresponding angles. If they're in the same position on each line, they're corresponding angles. So angle 1 and angle 9 are corresponding angles. What else? Remember how I said we can make the argument that these two lines that run from up to down are the normal lines and the ones that run from left to right are the transversals? That's also true. Those are transversals too. So it's kind of like if you were to flip this around, angle 1 would be here. It would be on this part of the blue line. Angle 3 would be on the same part of the second blue line. So you can say that angle 1 and angle 3 are corresponding angles. Okay, they're in the same position. They're in the top left of both lines. They're in the top left of both lines, so that would work. Angle 1 and angle 3, okay, what about angle 2? Angle 2 is in the top right of the first intersection of the lines. Well, so is angle 10. Angle 2 and angle 10 are corresponding angles. They're in the same area. Alright, so then we can also look at angle 2. Angle 4 is in the top right of this line also. Top right, top right. So angle 2 and angle 4 are corresponding angles. Alright. So let's look now at angle 5. Angle 5's in the bottom left of the top line. Well, angle 13's in the bottom left of the second line, so we have angle 5 and angle 13. Those are corresponding angles. And then angle 5's in the top left of this intersection. Angle 7's in the top left of that intersection. So angle 5 and angle 7 are also corresponding angles. Now we have angle 6. So we have angle 6 here. It's in the bottom right of this intersection. Angle 8's in the bottom of that intersection also. So angle 6 and angle 8 are corresponding angles. And then we have angle 6 is in the bottom right of this intersection, angle 14 is in the same position at the bottom right of that intersection. So we also have angle 6 and angle 14 are corresponding angles. So corresponding, they're kind of in the same position with respect to the lines. Those are corresponding angles. Okay. Now, let's go on here. What about, we have angle 3's in the top left of this intersection. Well, angle 11's in the top left of that intersection, so angle 3 and angle 11 are corresponding angles. Now, what about angle 4? Angle 4 is in the top right of this intersection. Angle 12 is in the top right of an intersection in roughly the same spot. So angle 4 and angle 12 are corresponding angles. Okay. Now we have angle 7's in the bottom left of this intersection. Well, so is angle 15. It's in the bottom left of that intersection. So angles 7 and 15 would be corresponding angles. Then we have angle 8's in the bottom right of this intersection. Well, angle 16's in the bottom right of that intersection. So angles 8 and 16 are corresponding angles. Alright, we shouldn't have too much more. Now we have angle 9 is in the top left of this intersection. Angle 11's in the top left of that intersection. They're in similar spots, so angles 9 and 11 could be corresponding angles. You could argue those are corresponding angles. Then you guessed it, 10 and 12, those are corresponding angles. Angles 10 and 12. Then 13 and 15, angles 13 and 15, those are corresponding angles. And then, yep, you guessed it, angles 14 and 16, those are also corresponding angles. So, corresponding angles you're going to have the most of because they're with respect to what position they're in for each line in each intersection. If they correspond to the same area for each line and intersection, they're corresponding angles. So, to sum it up, angle 1 is corresponding angle to angle 9. Angle 1 and angle 3 are corresponding angles. Angle 2 and angle 10 are corresponding angles. Angle 2 and angle 4 are corresponding angles. Angle 5 and angle 13 are corresponding angles. Angle 5 and angle 7 are corresponding angles. Angle 6 and angle 8 are corresponding angles. Angle 6 and angle 14 are corresponding angles. Angle 3 and angle 11 are corresponding angles. Angle 4 and angle 12 are corresponding angles. Angle 7 and angle 15 are corresponding angles. Angle 8 and angle 16 are corresponding angles. Angles 9 and 11 are corresponding angles. Angles 10 and 12 are corresponding angles. Angles 13 and 15 are corresponding angles. And then lastly, angles 14 and 16 are corresponding angles. So again, you get corresponding angles when those angles are in roughly, if they're in the same position at each intersection, with respect to the lines that they're located. Those are corresponding angles. Now we're going to move on to another type of angles, which there won't be as many of. Not nearly as many of. We have the next type is called alternate interior angles. So now we're going to talk about alternate interior angles. Well, as you guessed, as the name implies, they're on the interior. So 5, 6, 7, 8, 9, 10, 11, and 12 would be your interior angles because they're on the inside of the lines, right? They're on the inside of these two lines, therefore they are alternate interior angles. Okay, so let's go ahead now. Let's deal with our alternate interior angles. So let's see. Alternate interior, you can think of it like they alternate. So if you just look at the two black lines here and just the one blue line, only consider the one blue line, what you have now is you would have 5 and 10. Angle 5 and angle 10 are alternate interior angles because the reason is because they're both near the black line, but they're on the opposite side of the line, the transversal line on the interior. So alternate, they alternate. They're the opposite. They're on the opposite side of the transversal. That's why they're alternate interior angles. Angle 6 and angle 9 are alternate interior angles. Those are other alternate interior angles. Alright, now let's look only at the black line with this blue transversal here. Well, angle 7 and angle 12 would be alternate interior angles because 7 and 12 are on the opposite side of the transversal line. Then you guessed it, 8 and 11. Angles 8 and 11 would be alternate interior angles. So that's really all we have. That's all we have, just 4 pairs of alternate interior angles. So angle 5 and angle 10 are alternate interior angles because they both run on the two main lines, but they're on opposite sides of the transversal line. Same reason you get angle 6 and angle 9 as alternate interior angles. And then you get angle 7 and angle 12 alternate interior angles. And then you have angles 8 and 11. Those are alternate interior angles. So they run on the two lines that don't touch each other, but they run on opposite sides of the transversal. That's why they're alternate. And then we got one more type. And then that should be it for today's lesson. The last type is called same side interior angles. We have same side interior angles. Well, they're kind of like alternate interior in the fact that they're in the interior of the intersecting lines, or of the lines in their transversals. They're in the middle, they're in the interior. But unlike alternating, they're on the same side of the transversal. So angles 5 and 9, those would be same side interior angles. Angles 5 and 9 are same side interior. So are 6 and 10. They're alternate interior because they're on the same side of the transversal line. That makes them same side interior. What else? 7 and 11, those are same side interior angles. And then you guessed it, 8 and 12. Angles 8 and 12 are same side interior angles. And that's all we have for same side interior angles. So today we talked about parallel lines, meaning that both lines are in the same plane. That's a criteria for parallel lines. They have to be in the same plane and not touch. Skew lines are lines that are in parallel planes. They're non-coplanar, and which means they never touch, but they're not parallel or intersecting in any way. So they're kind of unique. We talked about how we can have two parallel planes and then you have a transversal plane that cuts those, and that the lines of intersection of those planes are parallel to each other. That was a theorem I gave you today. And then we just got done talking about lines and transversal lines. We talked about corresponding angles if they're in the same position on each line. Alternate interior if they're in the interior in the middle and they're on the opposite sides of the transversal. And then now just same side interior if they're in the interior in the middle and they're on the same side of the transversal. So that's it for this lesson. Next lesson, we're going to talk about some properties of parallel lines, and we're going to get more in depth with the 3 types of angles we just talked about today. So I hope everyone has a good day. Take care.